Speaking of that, there's, I think, an ongoing battle between kubectl and kubectl. I don't. I started with kubectl, so I'm going to stick with it. Kubectl certainly rolls off the tongue better. Oh, Ryan, you're just another local into containers. Tell us a little bit about your backstory and just kind of where you're at and how you came to LXD.
Yeah. Let's see.
That's a nasty trick. Alan, was that you?
We got a winner?
Yeah.
That's okay. Saving power. My name is Ryan Harper. I work at Canonical. I've been there for about 3 years, and prior to that, was at IBM Linux Technology Center right up here in North Austin, working on x86 virtualizations and then KVM. So I've been an enterprise VM guy for a very long time, and joined Canonical. And they had been doing a lot of work in early LXC, doing maintenance there, and running a lot of the early namespace patches and things like that let them do things really well with that. And I was, somewhat skeptical from a VM guy's perspective. Like, it just doesn't seem, I wasn't convinced, And then one of the kind of first things that we needed to do, or that I had to do on my job was, hey, you've got to run a very large set of different applications and things on different multi-vendor nodes and make it all fit and not have any machines idle. Right. And so we ended up turning to using LXC containers at the time to split out the different services. It was an OpenStack deployment, and sort of pack everything in alongside either next to VMs or just single instance and then a bunch of different containers side by side. And the other one, the one that kind of really blew my mind, was one of the maintainers for LXC, Stefan Graber, was running he does a lot of networking stuff. So he was doing an internet simulation on his laptop, and he had about 1,000 containers running and doing, BGP router gateways and simulating all this kind of.
What kind of laptop does he have? Was it?
I mean, this is 3 years ago, so it was maybe like Core i3 and like 8 gigs of RAM, and that was it. And
yeah.
And I was like, this is some serious stuff,
Just a quick show of hands. So we're talking about LXD, and we're also talking about LXC. And so all kinds of container technologies out there. But I thought I'd ask, as we kind of turtle on into LXD and LXC, who's had hands-on, or who's kind of oriented towards LXC versus other unnamed container technologies? Very good. Okay, yeah, there's a few of us out there. Okay, well then good. So this is, lots of folks are gonna learn some things today. Cool. Speaking of learning some things, just, I've come to understand a few kind of cool technologies from Canonical recently. Maybe we'll touch on some of these around fan networking and the like. Juju as well, just more powerful than I recognized. But so your background then, more like you were talking about coming from IBM, kind of, sort of conventional virtualization in and around KVM, VMs itself, which I think is a perfect setup for people coming to understand LXD and LXC. I'm going to digress here for a second because there's this connection point. Some of you have suffered through presentations I've given at prior Microservices and Containers Austin meetups, and I had at one point, stuck my foot in my mouth isn't quite the right thing. I think I just wasn't ready to sort of crisply describe the difference between an application container and, call it what you want, a machine container, a system container, an infrastructure container, and just how do those terms, where does LXD come into, and can you just maybe even do a better job than I did last time at describing the difference between those?
Yeah, I'll do my best here. LXD is a REST API manager service on the host that provides access for launching containers using Linux container technology. LibLXC is the library that drives the configuration of kernel and lots of other things that kind of give us this nice, container object. And so from a container on Ubuntu via LXD, spawns a root image with the SBIN in it that is inside it itself. And so that's going to come up just like it would on bare metal or in a VM, in which case it will then run the real NIT in there and spawn TTYs if you have one, SSH, and the other services that you might run. And so that's been labeled a machine container for us, and it's been useful to sort of talk about that as a way of versus like an application container, which may only run one process. Obviously can run others, but typically application containers focused on just that application, not necessarily any other services or processes running within there.
You may have done a better job than I did last time. I think we had a lot of confusion and our presentation went to total crap when I said those two terms. So maybe just to recap what you said, sort of application containers on the end of the spectrum where you wouldn't expect SSH. Ideally, in a perfect world, maybe a singular process offering up maybe a REST endpoint or something like that, or doing its thing, but a singular process, probably short-lived as well. And then over here, and the reason we're describing this is because LXD really brings some management and kind of manageability to the other side around machine containers. These are more longer-lived. You might have you were talking about TTY. You might have SSH. You'd even have the full. And you're gonna describe this better than me, but just the full OS.
Yeah, absolutely. I mean, the actual OS that you run may be very small and tiny, but for Ubuntu, we want to have the same OS image running wherever you see it. So if you're launching an instance in Amazon as a VM, or if you're launching it in a container inside that VM, or if you're on your laptop and you launch it there, we want that sort of same Ubuntu set of programs and the versions and things to all be the same, really blur those lines between the different technologies that is hosting that Ubuntu developer experience.
Okay, and so to me that's so interesting because even the title of our meetup is Microservices and Containers Austin, and the two, I think like Brian and other folks were talking about earlier, really kind of go hand in hand. One facilitates the next, and but there's also, and I think it was it Kevin was up here earlier from Booz Allen Hamilton was talking about lifting and shifting. I think old applications and. I start to think about all of the ways in which something like LXD facilitates these other use cases. What types of use cases do you find people gravitate towards running a full machine container and using LXD?
Oh, the sort of interest that we've found from some of the enterprises that we encounter, they already have that collection of VMs that they've been taking care of that have an existing application stack, and they're looking for performance and other aspects that is not readily available without a lot of skill in terms of VM configuration, getting the IOPS. Specifically, latency is one of those things where it's not it's easy to not get correct, and so being able to kind of lift up that stack that they've had and place it down inside a container instead of the VM, they can get some instant benefits from that without having to dramatically change the stack that they're already familiar
without
with.
rewrite, right? I mean, this is more of a lift and shift, or this facilitates that type of okay. Very good. Well, so the other things kind of coming to, by the way, there's some kind of interesting things, I think, capabilities that I don't think other container orchestration runtimes like Docker or Rocket necessarily have. And I'm just coming to learn this myself, that along those same lines of different use cases around these, LXD and kind of the, the containers that these machine containers are things like the ability to pull a file out of a running container. It might be long-lived and it's written something locally and you can go pull that out, but just anyway, my mind was blown a little bit earlier that hey, that was front and center. So as you talk about LXD and people come to understand it, there's this notion of a type 3 hypervisor is almost how LXD has been described.
Yeah, Dustin Kirkland from Canonical spent some time talking about that. And I think that was mostly to just capture the concept that, the LXD service and having an API and being able to launch and run these instances, we can call it a hypervisor just to aid the thought about like, we're going to run more than just a single application in this thing, right? So if you're looking for, if I've got existing sets of VMs and things, I can kind of mentally have a picture about, what we're doing with that. So yeah,
Yeah, people, just again, my mind goes back as people here kind of come to understand, well, both LXC, I think, but also LXD as a piece of technology. Again, those use cases where people want a long-lived container and they want that full machine, that machine container. One of those is the notion that I've been doing a little bit of studying myself and some writing on container networking, and I think in container networks, out of the box, you start small. You'd likely get something like a Linux bridge is probably the default type of networking you might come to. But another one then, as you go to run something across multiple hosts or in a hybrid fashion from on-prem to some cloud, that you start to look towards overlays and the encapsulation of those packets across hosts. But there are also the notion of underlays, which really helps bring your containers and the IP address that they have right into the host's network namespace. And so I'm going off on this harangue because I got to imagine that IP VLAN or Mac VLAN or Mac VTAP, are kind of maybe a popular way of networking within LXD. Am I looking at that right?
Yeah, as you mentioned, the sort of out-of-the-box configuration, of course, is setting up a bridge. It's easy enough to, make that just work out of the box on everyone's laptop. But generally, any of the host networking, technologies, if you've got, networking on the host, we can connect a pair, virtual Ethernet pair inside the container to that. Or in some other cases, some vendors are interested in accessing some of the hardware directly. So if you've got, not necessarily having to do an SRV, but some kind of high-speed networking, you can hand that directly into the device or into the container. So for latency-sensitive applications, that's something that they're interested in.
I got to imagine that just resonates with network engineers, network administrators a lot more easily, those underlays, the ability to address the container as something of a first-class citizen on the network. So that's just another kind of way, I think, of contrasting against the way in which networking gets done, maybe with application containers, so to speak. So now I keep kind of making the difference between application containers and machine containers. Now, does that mean that LXD, isn't a good fit for application containers? These smaller, short-lived processes?
No, it's complementary, right? So you can run Docker inside a LXD container if you like. That's certainly available. So however you want to package up your solution, in your image that you run, whether you run that via Docker or something else, that can be done. So it's no different than a VM in that regard.
Oh, nice. Okay. It's also always interesting to hear people, drink their own champagne or sort of eat their own dog food, if you will. Are you guys doing that at Canonical, or just using LXD and?
Absolutely. So one of the, OpenStack's kind of a big thing for us, and so we have a reference architecture where we describe here's how we lay out, an OpenStack cloud when we build these, and LXD's part of that. There's a Nova driver, Nova LXD, that actually registers in there in the cloud as a compute node, and then can be scheduled just like any of the other compute nodes. So that's important from when we go in and talk to telcos. This excites them from give me low latency access to compute services in OpenStack. The other place where it's common is just in developer workflow. So day to day, it's something that I run all the time, simply because the tool's there. I can say LXC launch Ubuntu : trusty, and I've got a trusty instance, or any of the cloud images that we work with on day to day. So if I'm fixing a bug or working on a customer problem, it's right there, and that makes it.
Yeah. Yeah, well, and so you mentioned LXC launch as sort of the Docker run, if you will, sort of the equivalent. Am I getting that right?
Yeah. So there's a command line component to LXC where you interface with the LXD is the daemon that's running the REST service, And it's got just a very short number of verbs for doing, launching, running commands. You mentioned the push and pull as well to, grab things in and out. There's image manipulation and some other things like that.
So for those that are familiar with, Docker Hub and other types of places to pull in, other public repos, how does that work with LXD, LXC?
Right. So there are two major repositories. So the Ubuntu images are hosted on the same place that the cloud images are, cloudimages.ubuntu.com. And it's the same image that we run. I mentioned that earlier. So those are pulled from there. There's also a community-run repository at images.linuxcontainers.org, and that includes other types of FreeBSD, Debian, Fedora, CentOS, those sorts of images are hosted up there, and they're both available built into the client. Both of those are registered as remote image servers. You can set up your own if you like as well, and you can just reference those in your sort of, it's kind of like the Docker run. They have a label that goes into a repository. So Ubuntu :trusty or Ubuntu-daily :xenial. Or images for the community one, Fedora /24/AMD64.
Nice. And I see all the examples you're tossing out are, for the most part, OS examples, or that machine container again. And going back to that, just my mind begins to reel about all of the challenges that people have had, managing, orchestrating VMs. And one of the things that I noted with LXD was it's taking advantage, it seems, of CRYU and snapshotting. What is...
Right. So CRYU is a checkpoint restore in user space. It's a...
It's kubectl, by the way.
Oh, I know. I figured I would put one in there. Just so the checkpoint restore infrastructure in Linux for extracting process state. We're active in that project to use that to basically migrate a container from one host to another. And LXD contacts another host with LXD and then can coordinate the migration of a container, its running state, as well as the snapshot and the image that it's running on. So very much similar to the same kind of services you'd want out of a VM host for doing live migration. We have that as well in LXD.
Well, that's powerful, and that's not necessarily something that you hear about as particularly a need for applicating these things that are intended to be shot in the head, but more for over here. And so, are there for CRYU? Are there any ZFS or other file system specific things dependencies that you'd have to have on your hosts? Also, just in general, I know LXD. I'm going to toss in two questions at once. LXD is. I think comes out of the box in a relatively recent, version of, Ubuntu LTS. But it is LXD, I tossed in two. Is LXD tethered to Ubuntu? Does this only work in that OS?
Well, I'll take your first one first. So storage technology-wise, there are a number of backends, simple file system, Btrfs, overlay, works with LVM, and then most recently in the 1604 release, we've added ZFS by default, and so the ZFS as a storage backend is in there. And so it's been very, very good for anyone who's used that. It is very fast. It just works, and it makes a lot of things super easy.
Folks were talking about ZFS a little bit earlier, and just are you guys? I don't know if you know, but are you guys continuing to receive heat over the inclusion of ZFS in terms of licensing or is that a?
I mean, it's like lawyers. Opinions of lawyers. I mean,
Okay, yeah, fair enough. Very good. Well, then on that question about LXD being, so it's out of the box available within Ubuntu 1604 LTS, but is it tethered to that OS or?
Right, that was your other question. So the LXD itself is a REST API for spawning the containers. At its heart in the implementation, we're calling into liblxc to create the containers, but it's not necessarily tied to any virtualization technology particularly, you could spawn something else, or call into something else, given the information in the call. When you're saying, this is the root FS image that I want to run, these some of the parameters that in terms of configuration limits and things like that. So yeah, there has been interest with other partners of reusing the same API and then putting a different technology in the back end. So we've had some partners come to us say they really like that the REST API. We're just going to plug in a different sort of virtualization backend on the other side, and that's just kind of dropped in, and then they get the same kind of, the client just behaves the same.
Sounds like you guys learned a lot from the sort of your OpenStack orientation and being all about the APIs. It sounds like you guys have gotten pretty good at that if people are leveraging the LXD. So speaking of OpenStack, you mentioned it before, but going back, this notion that one of the ways to interface with LXD and have it run LXC containers is via a Nova compute driver, right? And why would someone choose to use that versus another compute driver?
I mean, for us, it was about being able to spin up the same machine containers, but with greater density and lower latency without that vert overhead. So from the interest that is really driving the customers that come to us about that are a lot of the telcos and VNFs and things like that. They're very latency sensitive in their applications, and so being able to provide that in an OpenStack context is something that really resonates with them. That's what they want to be able to do, is take this workload that we've been running and driving in the cloud, and then really focus on getting low latency for the applications.
Speaking of OpenStack, Canonical software, and just and containers, another piece of software that jumps to my mind, and it's about service model orchestration, is Juju, which has been there for a while. I only recently kind of dipped both toes in and really found out just quite how powerful it is in its abstractions. I wanted to ask, just as we go to talk about Juju a little bit, just anybody charming out there? Anybody tossing around Juju? No one has cracked into that power. Yeah. Well, good. And then this is a good thing to talk about. Maybe you can just describe what the project is to people.
Yeah, I'll kind of talk about how I use it. I'm not on the Juju team, but service modeling in terms of connecting the different applications and services that you need in a way that you can build your applications and the relations that they need, and then deploy them to different substrates. So Juju can talk to the different clouds or local host, and has different providers. One of the most recent things that came out for LXD was the Juju agent can talk to LXD, and so this allows a lot of the discussion earlier about I want to deploy on my laptop the same way that I'm going to deploy in production, having the LXD provider so that Juju can say I'm going to spin up these number of containers, they're going to have these things in them, and then have that all run. And then it's the same whether you're doing that with your local provider on your laptop or whether you're pointing at an OpenStack cloud.
Yeah. One thing I can't help but connect the dots here, because there's starting to become a theme, I think, for me, Tim, wherever, about just, I spent some time at ChefConf, I think it was last week, but learning about Habitat and Supervisor and their supervisor as one. And just, now I'm hearing about Container Pilot, kudos, but also this Juju agent that gets, so Juju as a system, as it models out a given application. I think one of your flagship examples is sort of OpenStack as just an application, and you can use Juju there's been some demos that have just, Mark Shuttleworth has given that are just phenomenal, but goes and deploys an app, but it also leaves behind, I think, an agent. And that's kind of, I begin to draw some parallels between those types of, health check kind of monitoring agents that are there. So,
yeah, it was very eerie for me to look at the presentation, looking at the, here are the hooks, here are the stages. I call out to get the information about what I need to know, so that that's a lot of that's built into the Juju language in the agent. There have the hooks that run. There's relations between parts where they exchange data about what's the address of this, what are the credentials for that, and so that was very familiar to me looking at that stuff, and I was like, yeah, this is it's very encouraging to see the same kind of kernel of an idea pop up organically in different places, and even if they're not using your tool, but that concept really that pattern is very cool to see.
Very validating when you see different folks coming to the same thing.
Yeah.
Well, speaking of different folks, but just questions, is probably a good time to take some of those if folks have them. Is everybody? I know we talked about a few different technologies, but just for LXC and LXD, are those resonating with people? I mean, LXC being kind of the container runtime, LXD being a manager of those. Any questions there for people? Just kind of why would Gabe?
So these machine containers, three things that always are important comparing to VMs is how good are they isolated, how big is the footprint, and how good is the startup time of the latency. Can you compare that to typical VMs?
Yeah.
Repeat the question.
Yeah, that question was just sort of general comparison between a container and a VM, startup time, memory footprint, and isolation capabilities. From my perspective, I would sort of say they're about as in terms of isolation, they're equivalent. VMs have, depending on how you have it configured, may have additional surface area because they're typically configured to do device simulation or other things that you wouldn't find inside a container itself. Memory footprint almost always is going to be in the containers space because you're not having to model a very large amount of RAM that's not really necessarily doing anything other than maybe caching on the VM case. And startup time, they also win just because they get to skip the BIOS and other things. There are a number of virtualization-based technologies out there that kind of try to, hack around all of those things. I think the Clear containers from Intel, for example, is a highly optimized, path that will run a container effectively in a VM, albeit super tiny and small, and they have very fast startup times.
So Gabe brings up a kind of a good topic. I think it's specific to LXD or LXD is, there we go again, Ryan, is security. And just AppArmor, SecComp, user namespace kind of from the beginning, as I understand. What
yeah, definitely. Unprivileged containers with user namespace, SecComp, and AppArmor profiles. So we want it to be non-root user, as secure as possible by default, and we try to make everything kind of just work that way. So that's it's not an afterthought, it's a requirement up front.
Okay.
Yeah.
That's.
I'm looking through the LXD website here. It seems to me like the LXD is really about optimizing the deployment of the container, and that I, as a customer who buys containers, that doesn't go against my bill. It goes against the vendor's bill, right? So LXD versus Docker, from my check writing perspective, doesn't get me much because they're both LXC-based systems. So my side of the equation is just the same. Is that a fair assessment of the difference between it, or lack of difference from my perspective of the tools?
Yeah, I mean, it's I would agree.
I mean, I have to disagree. You're saying that LXD provides an API management. Docker has no API, right?
They do. So most are probably just familiar with the Docker CLI, and then, but there are others more knowledgeable than me on their. Yeah, there's a fair. Yeah, there we go.
The only thing in the API thing, the LXD manager is meant to be a host manager. It's not going to manage a very large set of hosts and large set of containers. That's something that we feel is better already handled by something like OpenStack, for example. And so that's why we plug LXD in as part of that. So if you're going to do large deployments and scale outs and things like that, there are other layers that do a better job. We didn't want to sort of boil the ocean with this, with LXD, right? We wanted to do single node management for machine containers as cleanly as we could.
Nice. Other yep.
So prior to or whatever. And now in the LXD command, and essentially all the LXD commands, did they transition from having all logic there, and then that moved into LXD daemon, and then essentially all the LXD create and all that became just a bunch of REST API calls?
That's fair. So there's a new client that will call into the LXD daemon that's running on the host that has different verbs but are roughly equivalent to some of the capabilities in the past. The LXC client that you're referring to is LXC1. That's still available if you don't want to use LXD. It still uses the same liblxc. So we just kind of have a different interface in there, and then the daemon is able to do a lot of things with respect to image management, config management, network, other things that you kind of had to do by hand with just the LXC command line on your own.
Good question.
You mentioned App Armor as one of them. What else is LXD doing in its utilization of C groups, namespaces that Docker isn't? With CFS, are you getting like IO priority now, or did you bring in Arc?
I don't know about the IO priority in particular. So C group IO priority, I don't know if they've transitioned away from block-based device stuff. So my recollection on kernel C groups with IO limits was around block devices rather than file systems. How that intersects ZFS, I'm not entirely sure. In terms of the C groups usage, I would say it's roughly equivalent at this point now. So maybe a year ago, I think Docker wasn't using user namespaces by default. Daemon's running as root. They've done a lot of work to kind of close that gap so that they're kind of in that secure by default as well. But yeah, user namespaces, the network namespaces, you can, on your container, you can set memory and CPU limits. There's also a procfs kind of proxy that we have in there that allows us to provide sane values to the machine container if you've restricted memory or CPUs and things like that. So some of those things are faked out so that we're not passing host data. Uptime and other things like that aren't derived from the host, it's from the container itself, things like that. But I would say generally they're mostly equivalent.
Good question. Other questions? It was great, fantastic. Ryan, thanks for hanging out. This has been good. I learned a few things.
Cool, thanks a lot.
Very good.